All right, so any questions over section 5? We're gonna start section 6 today. And then, like I said, next week, we're really gonna review, make sure we get to know the law of cosines, law of sines really well. And then I think we have our semester final, which is just gonna be a quiz over sections 4, 5, and 6. I think that's on Thursday. I believe math and science is on Thursday. And then, I don't really know. All I'm really concerned about is the classes that I'm worried about. So I don't know when your other ones are. You're gonna have to ask your teachers about that. But I do know math and science, for the most part, dominate Thursday. So questions over section 5. All right, law of cosines is another way to solve, and it's on your trig cheat sheet that I gave you. It's another way we can solve triangles that aren't right triangles. And set up here, I guess. And it's used for when you're given different information, you know, in the law of sines, you know, for law of sines, I'm just gonna write that right here. For the, different color here. For the law of sines, I think we talked about angle, side, angle. If we that would be when we'd use the law of sines. Angle, angle, side, and also side, side, angle. Those are the 3 circumstances when we would use the law of sines. Well, we're going to use the law of cosines when we're given a little bit different information than that. Okay, and we'll talk about that in a minute here. All right, so once again, this is when we'd use the law of sines. Basically, the way I like to say it, the way I learned it back many years ago, is that if I was ever given what's called an angle side pair, I could use the law of sines. Now, what I mean by that, this would be an angle side pair right here. This angle and this side right here. An angle and a side opposite. If I'm given an angle side pair, I can use the law of sines. Similarly, if I was given this angle and this side, or this angle and this side. If I know a pair, because of the ratio idea, right? If I know a pair, I can use the law of sines. All right, an angle side pair. Now, the law of cosines does not have any ambiguity. There are some things that could pop up that might make us think a little bit, but we'll cover those as we go along here. All right, all right, now, realistically, these are the 2 circumstances when we can use the law of cosines. If we're given a side, an angle, and a side, or if we're given all 3 sides. Okay. Now, most textbooks are going to give you 3 different options, just like you see on your trig cheat sheet, as far as, you know, what you're going to use for the law of cosine, and that's just fine. Okay. For me, I like to remember fewer things, so I'm going to remember 1 formula. Or actually, I'm going to remember 2. Here's the kind of the defining characteristic of the law of cosines. These 2 right here are an angle side pair, like I described earlier, aren't they? Same thing here. And same thing here. All right, so that's kind of to me, that simplifies, to me, the law of cosines into basically just 1 formula. And if you want to remember all 3 or use all 3, that's perfectly fine. But for me, if I'm using the law of cosines, this is how I remember it. And you don't have to do it the way I do it, remember that. Okay, now I use the letter P because they are a pair. Okay, that makes sense? So basically, these 2, and once again, you don't have to do it the way I do it. These 2 are an angle side pair, and then these are just A and B are the other 2 sides. Okay, A and B are the other 2 sides. Now, basically, if you just remember one formula here, we're going to use the law of cosines to either solve for little p or big P. All right, that's really what we're going to be solving for. Okay, and we'll talk about an alternate form here in a few minutes. But, if you want to use all three formulas, go right ahead. That's not wrong. I just try to simplify things for myself. So if I use that bottom formula there, you can understand why I do that. Okay. Now, the way this formula right here is set up is it's set up to be used if we know a side, an angle, and a side. Okay. Now, once again, some of this will make more sense when we start going through an actual example here, which we're going to do next. Okay. So this is the information we have that information. We can use the law of cosines. And next, we're going to look at how we can use that information to help us. Okay. For the most part, the law of cosines, like I said, does not have any ambiguity. There are some circumstances that we're going to talk about a little bit, though, that might throw a little wrench in the system here. All right. Any questions so far? All right. So here we're given a side, an angle, and a side, and we're going to use the law of cosines to do this. Now, once again, if you want to use, the formulas in the book, that's fine. Mine is just a modified one of that, so I'm not trying to confuse you. Angle C, I'll say, is 25. A and B are 4 and 10. So for me, I'm going to say this is big P, this is little p. That's my angle side pair. Okay. If I know an angle, the side opposite is the one I'm going to call little p. You want to call it big C and little c, go right ahead, not a problem. All right. So the way I do it, and maybe I'll work through it both ways, and you'll see it. If I write it the way that the authors of the text would maybe have us write it, we'd say c squared equals a squared plus b squared minus 2 times a times b cosine 25. Okay. Now, the way I'm going to write it, p squared equals a squared plus b squared minus 2 times 10 times 4 cosine 25. So is it really any different? No. Okay. No, it's just that for me, I remember one formula rather than 3. Does that make sense? It's just a matter of the letters you're going to use. Well, to be honest, the hard work is done when we're using the law of cosines here. This is something that we can quite simply put in Desmos, and if we're in degree mode, we'll find c squared. So why don't you do that? You can type that all in one statement if you'd like to. All right, so once again, what we're finding here is c squared. What did you guys get for c squared?
42.
43?
Yeah.
43 point what?
49.
All right. Now, that's not the length of the side we're looking for. That's the side squared, correct? So, what is the square root of 43.49? 6 point something. What is it?
6.59.
So let's just say 6.6. Okay. So was that pretty easy to find that side? Yeah, that formula is pretty easy to use. Got to make sure you're in degree mode. And you just have to basically type things in, excuse me, as they are written. Okay. Well, now for the most part, if I'm going to continue solving this triangle, I think I would revert back to the law of sines now because I have an angle side pair. All right. So realistically, I need to find one of these other angles. Okay. I need to find one of these other angles and go from there. Now, to be careful here, we're going to talk through a couple things here. To be careful here, so we're going to use the law of sines now. All right. This would definitely have to be the largest angle in that triangle, wouldn't it? All right. And that's the one that could cause trouble with that ambiguous case, couldn't it? So to remove that possibility that we're going to maybe get the wrong angle, we're going to find this angle. Because then how can we find the circled angle? The three angles have to add up to what? 180. All right. So I'm going to find this angle down here that I made a little star near. Okay. So sine 25 goes with 6.6, the same as sine 4 goes with, well, that must be, excuse me, that's not right. Shouldn't be sine 4, that is incorrect. Should be sine of the angle, I did that wrong, and that's B goes with 4. All right, I fixed it.
So you always want to take what looks like the smallest angle?
Not what looks like, I know this is the smallest angle because this is the smallest side.
Yeah.
So right, it's not just by the looks, you know what I mean by that?
Yeah.
I know that that's the smallest angle, but yes, I would look at the smallest angle. Right, because otherwise we could run into trouble with, here. All right, so what do you, this is work we've done the last few days. What do you get for angle B? And like I said, I don't know what it is. And then maybe we'll walk through the issue that we could have. All right, so that's, and I'll walk through that. Anybody have angle B? What'd you get?
The number, but I don't think it's right.
Well, let's find out.
It's 0.64.
Is that the sine of angle B? Did you go inverse sine of something at the end?
No.
Okay, so that's why I'm asking.
Yeah, I didn't go for it.
Anybody get the angle? What'd you get, Thomas?
I have 14.8.
Anybody else get that? Okay, so I think that's probably right. Okay, you probably just didn't go the next step, right? 14.8. All right. Now, which means this is a really big angle, right? So that's 39. It's almost 40. So that's going to be 139.2. Is that right? And I'm just using subtracting to find that other angle. Okay, I'm just using subtracting to find that other angle. Okay. Now, questions on that? Now, watch what would have happened if we would have tried to find this angle up here. Okay, just bear with me here. Sine A goes with 10, the same as sine 25 goes with 6.6. See what you get for angle A there. I think I know what you're going to get, but what do you end up with? What'd you get? You didn't get 139.2, right? What'd you get? 40.8? 39.8? Do you see why we want to find that smallest angle now? Because this angle and the angle you just gave me are in different quadrants, right? So that's why we'd want to find the smallest remaining angle in this case. When we go back to law of sines, find the smallest angle remaining so we don't run into trouble. Because here's what would happen if we did that. Let's just say we did it that way. Okay, this was 4, this was 6.6, this was 10, and this was 25. So this angle was roughly 40, right? Wouldn't that make this angle what, like 125? Why is that out of whack? It can't be the biggest angle, right? So do you understand why I say find that smallest remaining angle? Okay, so we avoid that issue.
My numbers are wrong.
Okay, we'll get them right. What's wrong? What do you mean? What do you mean? What do you mean they're wrong? What? Are you in degrees?
No,
I figured it out.
Figured it out? You think I'm wrong? I didn't give the answer.
No, it's right. That answer's right, but I don't know how I'm wrong.
Okay, that's due to rounding. That's probably due to rounding. Okay, it could be due to rounding. What did you have added up there?
That's the same page.
Let's see what you wrote.
In the blue box.
14.8?
Yes.
39. Maybe it's is this supposed to be 140.2? This one right here? That's what she's saying. I think you're probably right. Maybe I subtracted wrong. First mistake I've made this year. But it's early in the year, yeah. All right, so that should have been 140.2. Okay. So that's a little thing to remember. If I use a law of sines, excuse me, if I use a law of cosines with side angle, side information, I should then go, I'm going to use a law of sines, which you don't have to. We can use a law of cosines again if you want to. This is how I do it though. Find the smallest remaining angle. Okay. Because then we won't run into that problem. Right there you can see those are the angles that we found. 140 or 130, 140.2, 15, and 6.6. Or not 6.6. We found the missing sides. Okay. All right, so that little strategy to find the smallest remaining angle when using the law of sines is a good one. All right, now we're going to look at a couple more examples because we need to look at side, side, side. Now, we're going to go to the whiteboard here now. All right. Now, let's say we were given sides of a triangle that where A is 1, where B is 5, and C is 4. Okay, this is side, side, side. So obviously we're going to have to find an angle, right? Now, I set up a problem here that doesn't work, right? Because we have to review something, right? If we tried to use a law of cosines here, which we can, here we go. I'm going to say B squared equals A squared plus C squared minus 2 times A times C cosine B. All right, we're going to do some math here. Is that right? Hold on a second. Did I do this right? Am I multiplying correctly here? Yeah, I am. But it, all right. And then we would do this, right? Well, what's cosine inverse of -1? Find it. Can an angle in a triangle be 180? No. Can't, right? Not possible? Now, the sides I gave you aren't going to work. And I knew that to begin with because I wanted to, we're going through something and learning, or reviewing something. Do you remember something back in geometry called the triangle inequality? And if you don't, I mean, maybe you do, maybe you don't. Basically, it said the sum of any two sides of the triangle has to be bigger than the third, didn't it? Do you remember that? That's not happening up here, is it? All right. So we could just maybe, if we remember the triangle inequality, we could just say there's no way that can happen. And this reinforced that there's no way that can happen too. The triangle inequality, basically, if this triangle inequality isn't met, you're gonna have a triangle that two sides don't meet, correct? It's not gonna meet. Basically, what Jacob was just doing, basically you're gonna have a triangle if you have 5 here, and you have 4 here, and you have 1 here. Do you form a triangle? Those are my 3 sides. No, we don't form a triangle. So it gets flat. Hence the 180. All right. So that's not possible. That is not possible. Okay. Just be aware of that. That might happen from time to time. Now, another thing I like to do, and I'm going to, maybe this is something you're going to want to do. Is if I'm ever given side, side, side information on a triangle, my first job is going to be to find an angle. Okay. So over there at the bottom, I put alternate forms. What we can do is we can take this formula and solve it for this angle P and never have to do that again. That seem like a good idea? We're going to do all this algebra right now and we'll never have to do it again. All right, and this is something you're going to want to, you don't need to write down all the work, how we get there, just follow along. But the end product, you're probably going to want to write down. So if I'm trying to solve this for P right here, would this be a good first step? That's just one step of algebra, right? Subtracted the same number from both sides. And you don't need all this work if you don't want it, okay? But it's up to you. Okay. Now, this next little step, we're gonna move things around here. Basically, what we do from the previous step is I just moved did I just move this negative factor from the bottom to the top? It looks cleaner, okay? That's what I'm gonna say, it looks cleaner. A squared plus B squared minus P squared all over 2AB. And that's equal to the cosine of angle P. So when all said and done, cosine inverse of A squared plus B squared minus P squared over 2AB should be angle P. So this is what I call the alternate form of the law of cosines that's used to find an angle. Right? Doesn't it make more sense to do all that algebra once rather than every time you have to use it? I think so. All right, so that's what like I said, that's what I refer to as the alternate form. Because if we don't use something like this, every time we find an angle, do we have to do that same algebra? We would. So let's just make our lives easier. All right, let's use one of them. And once again, angle side pair is what I'm dealing with a little p and capital P. And I don't think you're going to see that in the book, but I just think it makes things easier. So I probably jot that down on my note sheet somewhere, but it's up to you. Once again, that's useful when we're given all three sides, when we're trying to find an angle. Okay, so let's use that now. All right, so let's say we have sides of a triangle where A is 5, B is 9, and C is 7. And this one does fit the triangle inequality. All right, it does. Okay. So here we go. Now we just have to figure out what angle do we want to find. Now this is maybe going to sound like it's contradicting what I said earlier, but if we're going to use the law of cosines to find an angle, I'm going to find the largest angle. All right, law of sines, I'm going to look for the smallest angle. Law of cosines, I'm going to look for the largest angle, which would have to be angle B, wouldn't it? All right. So angle P is going to be cosine inverse A squared plus C squared minus B squared over 2 times A times C. And I did some of the squaring in my head. You don't have to if you don't want to. You can't do it in my head. Do it in your head. Then it's just a matter of finding that angle by, plugging in what you have. All right, so I want you to do that. All right, does anybody have the measure of the angle for me? The nice part about Desmos is you can type this in just as it looks in one shot. And if you don't want to find 5 squared in your head, you could put 5 squared plus 7 squared minus 9 squared, right? What's the measure of our angle?
95.7.
So I'm just gonna say 96, okay? Okay, everybody okay with that? Everybody able to find that angle? I mean, if you're in degree mode and you type it in as it looks, or if you type it in as 5 squared plus 7 squared minus 9 squared, on the old calculators, it was a bear to type that all in at once because it would go off the screen. You know what I mean?
I got undefined.
Then you screwed up. No, I just.
It looks like that.
You have 9 and 7 inverted. It should be 5 squared plus 7 squared minus 9 squared.
Oh,
Right? You see 25 plus 49 minus 81? So you have the numbers.
97?
This is 5 squared plus 7 squared minus 9 squared. Okay. You see that?
What is it? B9?
Yeah. But we're using our alternate form where these two are a pair. Okay. Do you want to write down 3 alternate forms? You can. All right. These two are the pair. These two are just two other sides. And if you want to, like I said, if you want to write down on here, there's 3 forms of the law of cosines. If you want to rewrite 3 different alternate forms from those, go right ahead. All right. If that makes more sense to you, that's fine. Is that, you understand what I'm saying?
Yeah.
I'm kind of using my way, and maybe that's not jiving right now, but just treat this as an angle side pair, and these are just the 2 other sides. Okay. Now, once we have that, we just have to find one more angle, and then we're what? Then we can use angle addition. Now, for me, I'm just going to find one of the angles. It doesn't matter which one anymore, but I'll find the smallest one. Sine of, I'll call it X. We could find that angle, and then we're home free, correct? We can find that angle, and then we're home free. Because then we have 2 angles, we can find the third by the triangle sum problem. Right. So does anybody find that angle X? Realistically, we should know how to finish this one off, but we'll do it together. And that's going to be the smallest angle in the triangle. Anybody have it? 33.5? Sounds good to me then. So if that angle right there is 33.5, we can find this other angle by saying 180 minus 96 plus 33.5, which is going to be 120, almost 130. So it's going to be 50.5. Is that right? If I did my math right? Is that right? You guys have the calculators. Is that correct? 50.5? If it's not, if I added wrong, let me know.
No.
That's right. Okay. Like I said, I'm doing it in my head, so I could have messed it up. So we're going to come back tomorrow, talk a little bit more about the law of cosines, and talk about there's 2 area formulas that kind of go along with the law of sines and the law of, they kind of go along with the law of cosines more than the law of sines. All right. But we're going to spend another day on this. And like I said, next week, a lot of review of law of sines, law of cosines, quiz on Thursday. So that's where we're headed. Does anybody have any questions? All right. I will put